We're going to continue to take a look at how to solve radical equations. The difference in this lesson compared to the previous one is that there's going to be an equation in here. Instead of linear degree 1, it's now going to be a quadratic or degree 2 equation. We begin with a radical equation. It is a radical equation because there's a variable underneath that radical sign. The process remains the same. We're going to begin by stating the restriction. Because this is a square root, we're going to take that radicand. We know that it has to be greater than or equal to 0. So we're going to isolate for that variable and get our restriction. So we know that in the end, n has to be greater than or equal to 4. We're now going to isolate the radical. So if this equal sign is kind of like the divider, we want the radical by itself. So we need to remove that 4. I'm going to bring it to 0 by subtracting 4, and I'm going to do the same thing on the other side to keep that equation balanced. We now need to remove this radical by squaring. And again, we have to square both sides to keep it balanced. So I'm going to square the right-hand side, and I'm going to square the entire left-hand side. So let me start with the right-hand side because it's a little bit easier. When we square the radical, it cancels out, and we're just left with that radicand. Over on the left, we now are squaring a binomial, so we're squaring this entire thing. So if you want, you can even just write out the base times itself 2 times, and then when we multiply 2 binomials, we have to FOIL. We're going to multiply the first terms, the outside, the inside, the last terms, and then we're going to combine those like terms together. I'll show you a little trick from how you can go from here directly into that trinomial that is simplified instead of having to write this out and FOIL it out. So we know that if we have a binomial squared, so that means we have the exact same thing in each of those brackets. When we multiply the first terms, it's always going to be this times itself. So I say, okay, let's square the first term. So n squared just gives us that n squared. And then we know that the outside product and the inside product will always be the same. So I always just take the product and double it. So here, if we multiply n times negative 4, that's going to give us negative 4n, times 2 gives us that negative 8n, because we're always going to have this and then this. And then we square the last term. Now watch the sign here. Negative squared becomes a positive, so we're going to square that last term because we know it's always going to be this times itself. So I say, okay, let's square the first term, double the product, multiply those together, times it by 2, that gets us that middle term. Don't forget that middle term. And then we're going to square that last term. I now have a degree 2 equation. The highest exponent on my variable is a 2, as opposed to the linear equations that we dealt with in the previous lesson. They were all degree 1. We're going to be dealing a lot more with degree 2 quadratic equations in an upcoming unit. But what we're going to do is if we have a degree 2, we're going to move all terms over to the side where that squared term is positive. So what I'm going to do is subtract 2n to bring that side on the right to 0 from the n term. I'm going to add 8 to bring that constant term to 0, and I'm going to do the same thing to the constant term on the left side. And then it's really important, we want to keep this as an equation where we can get the value of n. We're going to say this is equal to 0. So now we have a quadratic equation, and there's a few ways we can solve this. We can use the quadratic formula, which we don't know how to do just yet, but we will eventually, or we can factor it. And at this point, you do know how to factor, so let's go ahead and factor. So we can see that it is a trinomial. We do not have a greatest common factor that we can remove. If it's a trinomial, we know we're going to begin by multiplying the a times the c. So the coefficient in front of the n squared, which is 1, times the constant term, which is 24. I need 2 numbers that will multiply to that product, so in this case 24, and add to the b value, which is negative 10. So the 2 numbers that will multiply to 24 and add to negative 10 are going to be negative 6 and negative 4. One of those numbers is the outside product. One of those numbers is the inside product when we FOIL. So however you want to factor, some people do cross products, some people do decomposition, some people do reverse FOIL. I'll link a video below if you need to go back and review some of your factoring skills. But I think reverse FOILing ultimately is going to save you the most time. So we want to say, okay, the first term is n squared. So we have n times n gets us back to that n squared. Knowing that these are the outside and inside, I'm going to say 1 times what number will give us one of those. So I just happen to put in the negative 4 first. It doesn't matter because we do have a leading coefficient of 1 on that first term there. And then we're going to say n times what is going to give us that other value, so negative 6. And then the last term is the check. So negative 6 times negative 4 gives us that positive 24. Now, This times this is going to equal 0. We're going to set each of these factors equal to 0 and then solve to get the value of n. So I'm going to say n minus 6 is equal to 0, and you might be able to see at this point that 6 is the number that's going to go in there that will make that 0. And then on this case, if we move the 4 over here, n is going to equal 4. We end up with two solutions, but we have to now check for extraneous roots. So the first thing we're going to do is check the restriction. N has to be greater than or equal to 4. Well, this is equal to 4, this is greater than 4. So both of those fit the restriction. And now we're going to verify this. So we're going to substitute it back in and we're going to check, does the left side equal the right side? And we have to do this one at a time. So we're going to start with 6. It doesn't matter what you start with, but let's take our first one here. And we're going to substitute that 6 every place that we see an N. So we're going to put a 6 here, and we're going to put a 6 here. Then we're going to go ahead and work this out. So 2 times 6 is 12, minus 8 is 4. The square root of 4 is 2. 4 plus 2 is 6. The left side equals the right side. So we know that 6 is going to be one solution to that equation. Now we need to do the next one. So we're going to take 4. We're going to substitute 4 back every place that we see an N, and then we're going to work that out. So begin here. 2 times 4 is 8. Minus 8 is 0. Now the square root of 0 is just 0. So I know that 4 plus 0 is just 4. 4 equals 4. So again, the left side equals the right side. So we also know that 4 is a solution. So this particular equation has two solutions to it. There are two values for n that when you substitute them back, the left side will equal the right side. Our next radical equation also has a square root. So I know that this radicand has to be positive or 0. So we're going to go over here. I'm going to move this 5 over to the other side. So when it crosses that inequality, it's going to become a negative. I'm going to divide out that negative 1 from both sides. And then remember, you have to flip that inequality when we divide out that negative 1. We're now going to isolate the radical. And because we're subtracting the radical on the left, I'm just going to move this radical over to this side so it becomes positive. And then because I want the radical by itself, I'm now going to get rid of that negative 7 on the right by moving that over. So remember, every time you cross that equal sign, the sign flips. All right, so now the radical is isolated. I need to square both sides to remove the square root. So we're going to square that side, and again, we're squaring that entire right side. So we're going to square this binomial. So we know that on the right-hand side, the radical is going to be eliminated. The squaring cancels the square root. Over here, do you remember that little trick? We're going to square the first term. So we're going to have n squared. We're going to double the product. So if you multiply, 7 times n is 7n, times 2 will give us 14n, and then 7 squared is 49. So you can always write out n plus 7 times n plus 7 and FOIL it if it's easier for you, but don't forget we need that middle term there. And now we take a look and see this is a degree 2 equation. So if it's a degree 2 equation, everything needs to come over to the side where that happens to be positive. So I'm going to begin by, I have a positive 5, so I'm going to subtract 5 to get it down to 0. And then we have a negative n. We're going to add n to bring that up to 0. And then again, it's really, really important in order to solve this, to make it an equation as opposed to an expression, you have to put that equals 0 there. We're now going to factor this trinomial. So again, there is no greatest common factor. We're going to multiply a times c together. So we're looking for two numbers that multiply to 44 and then add to that b term of 15. So we can see 11 and 4 are going to be the numbers. And then however you factor, go for it. But I'm going to reverse FOIL this. So we're going to have n times n gets us back to that n squared. These are the outside and inside products. So I'm going to say 1n times what gives me one of those numbers. And because it is a 1, this is the only time that you can actually just put that number in, because this happens to be a 1 here. And then we're going to say n times what gives us that other number there, which is 11. And then the goal is we need to get the solution. So we're going to take each of these factors, we're going to set it equal to 0, and then we're going to solve. And in time, you're going to be able just to see negative 11 is what will make this factor 0. Negative 4 is what will make that factor 0. So we've got our two solutions. Now, really, really important, we have to check. So first check the restriction. So we have to have less than or equal to 5. This happens to be less than 5, and this also happens to be less than 5. Now we have to substitute it back in and check, does the left side equal the right side? Now you can write this out the long way. You can do it mentally unless it specifically says you need to show your verification. or you can also do it on your calculator. All right, so we're going to do this again one at a time. We're going to begin with -11. So I'm going to go ahead and type into my calculator -11, and then right here you have a store key. So we're going to store that, and then up here beside the alphabet key you have a variable key. So we're going to store it as the variable, and we're going to press enter. So every time we put an X in here, then any kind of variable, our calculator is going to put in that -11. So we're going to begin by entering the left side. So I'm going to type in that variable and then minus, and then we're going to do the square root of 5 and then minus that variable. So that's the left side, and we're going to press enter. So the value of the left side is 15, and then we can see the value of the right side is -7. So -11 is not going to be a solution. The left side does not equal the right side. It's going to be extraneous. We're now going to go ahead and do the next one here. So we're going to start over. So we're going to this time put in -4. We're going to store that as the variable now and then press enter. So every time we put that variable, it's going to enter a value of -4. And then again, we're going to enter the left side. So we're going to have the variable and then minus the square root of 5 minus the variable, and then we're going to press enter. So the value of that left side is now -7. -7 is what we want to have there. So this radical equation has one solution, -4. -11 we have to indicate is an extraneous solution. With this next one here, you can see that we have a denominator that is a variable. So I'm going to state the restriction on that radicand. It is a square root, so we're going to set that greater than or equal to 0, and then we're going to solve for w, which happens to be -4. However, we know that w cannot equal 0 because we cannot divide by 0. So every value greater than or equal to -4 is okay, but we do have to specify w cannot equal 0. When we go to isolate the radical, so on the left-hand side we have this square root, we need to get rid of this divide by w. So I'm going to do the opposite operation, which is multiply by w. The w in the numerator will cancel with the w in the denominator, leaving us just with the radical. We're going to get rid of that radical by squaring both sides, and then because we do end up with a squared, it is a quadratic equation, degree 2. We're going to move all of these terms on the left over to the right. And remember, every time we cross that equal sign, the sign on those terms is going to flip. And then we're going to go ahead and factor this. So I need two numbers that multiply to -8 and add to -2. So I can see those are going to be my numbers. I'm going to go ahead and factor this. We're going to set each factor equal to 0 and get our solutions. Now, when we go to verify, and I actually did write this out here, we're going to do this one at a time. So when I put the 4 back in, every place that we see a W, we're going to put in that 4. We can work it out and we can see that the left side does equal the right side. So this is a solution to this radical equation. When we put the -2 in, however, so I'm going to put the -2 in each of those places and we work that out, we can see that the left side does not equal the right side. So we need to indicate this is an extraneous solution. This radical equation ends up having only one solution. And for our final example here, pause the video, see if you can work out the solution or solutions to this particular equation, and then come back and see how you did. All right, we have one solution, and that solution happens to be -1. -4 is another solution that you would have got. However, it is not a solution to this equation because when you put that -4 back in for that variable p, you're going to see that the left side does not equal the right side. So check your work here, beginning with the restriction. So that radicand p plus 5, we're going to set that greater than or equal to 0. And so when you isolate that variable, p must be greater than or equal to -5. So both of those fit that, which is why you need to actually substitute them back in to catch if there are potentially any extraneous ones. We're now going to isolate that radical. So I need to remove that -p. And this is a step a lot of students forget. So don't forget, we want to do that first. And then we're going to square both sides in order to remove that radical. FOIL this out. Remember that middle term there. And then we're going to recognize this is a degree 2 equation, so everything's coming over to the side where this happens to be positive. We're going to go ahead and factor, set your factors equal to 0, solve for the variables that will make each of those factors equal to 0, and then really important, verify those solutions.